My name is Paige James. I'm a recent graduate from Queen's University in the Department of Physics, Astrophysics, and Astronomy. And most of my research revolves around exoplanets, which are planets that orbit around stars that are not our sun. So when you look up in the night sky, you see all of those stars, and a lot of them have planets orbiting them just like ours does. I went to Queen's University, which is in Kingston, Ontario, and I studied physics. All of my research revolves around exoplanets, which are planets that orbit stars that are not our sun. Some of the coolest ones being the TRAPPIST-7 system, which are 7 stars or 7 planets that orbit the same star, and they all orbit closer to that star than the planet Mercury does in our solar system. And if you know about the order of the planets, Mercury is the closest planet to our sun. So the fact that there's 7 planets within that tiny radius is really interesting for us to study, and the star that they orbit is actually a lot less warm or hot than our star is, which means that these planets are cooler than Mercury is. Mercury is the second hottest planet. Venus is actually the hottest, them being the 2 closest to the sun. And as a result, about 3 or 4 of these could be in what we call the Goldilocks zone, which is the area in a star's orbit where it's not too cold, it's not too hot, it's just right, and the planet is just the right size that it can support life. So, for example, Earth itself is in the Goldilocks zone of our sun, and a huge part of our research is finding finding planets that are also within that Goldilocks zone. I actually have a really fun story about how I ended up in STEM, and specifically in physics and space exploration. When I was around your age, maybe a little bit younger, I went to Disney World and I had an autograph book, and I accidentally left my autograph book on a park bench in Epcot. And I was so devastated, I was so upset. I had been collecting these autographs for so long and they were all just gone. Except that was the one time that I wrote my address in the front of my book. My mom never let me do that, and for whatever reason, I said, I'm gonna do it this time, and I'm glad I did. 3 months later, I got a package in the mail, and it was actually my autograph book, and the guy that had found it and shipped it to me was there for the launch of STS-127, there being in Florida. And STS-127 is actually one of the flights that Julie Payette, who is the second female astronaut from Canada to go into space, was on. So he went to watch the launch of that because he was also an astronaut in training. And he went back to Houston and he continued his research or continued his training. And with my autograph book, he was able to send a whole bunch of really awesome things from NASA. So he gave me some pamphlets and some reading cards that were probably way above my grade 4 reading level, but that's okay. He sent me astronaut ice cream, which is one of my favorite foods in the whole world. It's just freeze-dried ice cream, but it's a treat whenever I visit one of the places that sells them. He also sent me a couple of model spacecrafts, and he sent me a keychain that I still have on my keys to this day from the Johnson Space Center. That was actually the summer of the 40th anniversary of the launch of Apollo 11. And Apollo 11 was the first spacecraft to ever land on the moon, and that's where the one small step for man, one giant leap for mankind comes from. So I spent that summer very excited about space and very excited to learn more. And that just started to pique my interest. And actually 2 years ago or I guess 3 years ago now, in 2019, I got to go down to Florida for the 50th anniversary of the launch of Apollo 11, which was awesome to see. Ever since then, I've been super excited about space. It's all I wanted to learn about when I was a kid, and that just continued into my post-secondary education. I loved physics in high school. It was my favorite class to take, and I don't know if that was because I'm good at math or if it's because I loved my teacher, but there's lots of different factors that went into me enjoying the subject as much as I did. And then in first year at Queen's, we do a general first year, meaning that you take just a bunch of science courses. So I took biology and chemistry and math and physics, and my physics course was the one that I liked the most, surprise, surprise. So I decided to major in it at the end of first year, and that's why I got my degree. Normally, when I am at a conference and I hear another woman in STEM talk about this, she often starts to talk about raising children and how that is traditionally the female's role and how that can be difficult for women who are in STEM. And I can see how that could be a struggle. It hasn't been an issue for me so far, but I imagine that it will be in the future. As well, there's just other challenges that come with being a female in STEM. Oftentimes I'm overlooked by my coworkers or my peers, and people don't take my opinion as seriously as others may. I know on multiple occasions in my post-secondary, I was paired up in a group with a whole bunch of guys and me, because there was not very many girls in physics, and I would say something and it would just be completely overlooked, and somebody else could say exactly the same thing. And then by the end of it, I started to not speak up as much because I was afraid. But once I really found my voice and I was able to speak confidently enough that people listened to me and people recognized that I was talking, it really changed my education for the better. I think the number one thing is that you can do whatever you want to do. You hear stories about scientists, whether they're at NASA or at universities or at other research departments, and they always seem like they're so out of this world. They're something that you could never obtain. And I know personally for me, when I was growing up, I grew up in a very small town, and there was kind of this mentality that anybody who was at the top of our class or anybody who enjoyed science was going to become a doctor, and then anybody that enjoyed history and English and writing and civics was going to be a lawyer. And those were the only two career paths that were designated for people who were intelligent. And that really put a damper on me because I didn't know that I could go to school and get a degree in something so cool and end up researching and learning all of these super, super cool things that I'm interested in. Don't get me wrong, it would be really cool to be a doctor or a lawyer, but my personal passion is for physics, and I didn't think I'd be able to find a career or find education in that, and I have. The other thing that I wish I knew was I wish I had a study routine. I was the kind of student in elementary school and high school where I didn't really need to study and I still got pretty good grades, and that really hit me hard once I hit university. I didn't know how to study properly for tests, and that ended up playing a damper on me because I wasn't able to study effectively, and I really struggled at the beginning of my first year, but eventually I was able to form that routine, and I wish I had a study routine. I was the kind of student in elementary school and high school where I didn't really need to study and I still got pretty good grades, and that really hit me hard once I hit university. I didn't know how to study properly for tests, and that ended up playing a damper on me because I wasn't able to study effectively, and I really struggled at the beginning of my first year, but eventually I was able to form that routine and I came out successful. My role model when I was growing up was definitely my mom. She was one of 5 children. Each of them was their first generation to go to post-secondary, and I always thought that my mom was the coolest person in the entire world. She has a music degree and an education degree from the University of Saskatchewan, and her resilience to get through that degree really made a difference in how she raised me. Now she's a teacher and she teaches mostly music, but because she was able to put me, or she forced me to go into music classes, I started learning about patterns and learning about numbers and rhythms from a very young age, which definitely helped in how much I knew about math and how easily I was able to learn this math. I also say that another one of my role models was Julie Payette, who I mentioned earlier on. She's one of the most famous astronauts to ever come out of Canada. She's done multiple missions, mostly on the International Space Station and on the Space Shuttle. The one that I mentioned earlier was STS-127, which was a space shuttle mission to the International Space Station. So if you've ever seen, I know I have a picture of the space shuttle up on my wall, but if you know what the space shuttle looks like, it basically looks like a really cool airplane. And what they're able to do with the space shuttles, or what they were able to do, is they could take off and then do whatever they needed to do in space, whether that was assemble the International Space Station or go fix the Hubble telescope. And she was a very integral part of that. And having her come out of Canada and be an engineer from Canada, and be a female engineer from Canada, is just something that I think is very important in Canada's history, in the history of girls in STEAM, and in the history of space exploration. I think that participants should consider a career in space exploration and in physics, because we're about to learn so much more and everything is about to get so much cooler. Currently we have the Hubble Space Telescope, which is orbiting around Earth, and they say that if Hubble were located in New York City, which it's not, it's orbiting Earth, but if it were located in New York City, it would be able to see a person standing in Los Angeles, meaning that it's such a strong telescope that it can span the entire continent of the United States. On Christmas, I'm sure some of you heard, but if you didn't, we just finally launched James Webb Space Telescope, which is going to be one of the most impressive feats in all of human space exploration. They say that while Hubble could view across the continent, James Webb Space Telescope could view one single taxi light in New York City if it was placed on the moon, which means it has so much more power. It can see so much farther. And the cool thing about space is the farther away we see, not only are we seeing a farther distance, we're also looking back in time. So we're about to learn, once James Webb gets all set up and in its orbit and it unfolds, we're about to learn so much about the universe that we didn't know before, and we're about to see so many things that we've never seen before. And the next few years, honestly, the next 10 or 20 years in space exploration are going to be some of the biggest in human history. Not only that, I obviously am very excited about James Webb because that's where most of my interest lies, but I'm sure many of you have also heard about NASA's initiative to return to the moon, the Artemis mission. They will be sending their first female ever to the moon, which is so exciting. And that is also in part done with Canada. So a lot of you will have heard of Canadarm, which is on the International Space Station. It's a robotic arm. Canadarm 3 is going to be on a very similar space station that orbits the moon. And Canada's robotics in the space sector are some of the most important things that we offer. And being able to say that we are the one country that did that and has contributed to space exploration in such an important way is really, really awesome. I think that the future is huge. What's gonna happen, I can't even begin to imagine all of the things that are gonna come out of the next 10 or 20 years in space exploration. I find that unfortunately there is still a bit of gender inequality in physics. One of the biggest issues I always had in my university degree was that virtually none of my professors were females, and that got a little bit hard because it's difficult to go up to them and explain how you're feeling about something, or explain that you're really struggling with something when they may not exactly understand. In my entire university career in physics, I had one female professor, and don't get me wrong, she was incredible. She's this really awesome astrophysicist at Queen's, and she's done some amazing work. She's written every textbook I've ever studied out of on astrophysics. But I wish that there was more. You know, I'm taking 8 classes a year times 4 years, you know, that's 40 classes or 40 professors, and only one of them was a female. And that's just something that I know myself and my classmates are trying to change. One area that I think that physics has really improved in is the amount of high school teachers. We had a joint Con Ed program at Queen's, which was also the education program, and they all got their degrees in their first 4 years in whatever field they wanted to teach, and then went on to teachers college. And we had a lot of females in physics Con Ed, which was really promising to see, because I know that that's going to be the thing that inspires lots of young girls and girls in high school to continue in STEAM and continue in physics. As far as the workplace goes, there are other just general inequalities that we see. I know I'm a young graduate. I graduated less than a year ago. I'm new to the workforce, and seeing that so many of the people that are in management positions and decision-making positions are males, it gets a little bit difficult to be somebody who is of a gender minority. You often feel like your voice hasn't been heard, but I promise that this is changing, and I see a significant improvement every single year. There's lots of initiatives to keep women in Canada and women around the world involved in STEAM. I know one of my favorite weekends of the year every year in undergrad was going to the Canadian University Undergraduate Women in Physics Conference, which was actually held at the University of Saskatchewan last year, which was very exciting. And then continuing on from that, I also got the chance to be on Canada's writing team for the International Women in Physics Conference, which was supposed to be held in Australia in the summer of 2020, but unfortunately that didn't happen. And that does happen every couple of years though. So the fact that there's people from around the world that are coming together to support gender minorities in physics shows me that there is going to be a very positive change in the coming years. And I'm very excited about the future of physics and the future of space.
Hi everyone, my name is Peyton Gilbertson and I am a science explorer at the Saskatchewan Science Centre. Today I'm going to be leading you through a coding activity. Together we are going to make an 8-bit game. First thing we're going to do is we're going to go to the website arcademakecode.com. That link will be in your package and should be linked on the website. But once you are there, we're going to click Create New Project. It is a big orange button that's on the left of the screen. Once you click that, there should be a little window that pops up that says Create a Project. We're going to give our project a name. I'm going to call mine Ocean Swim, just because that's kind of the theme of the game. Once that all opens up, you will see a wonderful screen that has a little mini player on the left-hand side, a column with a whole bunch of categories kind of in the middle, and on the right-hand side there's a canvas that has a green little alligator mouth that says On Start. So now that you're there, and we know kind of how the website's going to work, we are going to go over and we are going to find under the Sprites tab, there is an option that says Set My Sprite to Sprite, and then it has an empty box of Kind Player. We're going to drag that out and stick it in the On Start box, right in the middle of that alligator mouth. Now, your sprite kind of acts as your character, so we have to pick what that character is going to be. So if you click that gray box, it'll open up a window. Now you can draw your own character, but for today, I'm just gonna go into the gallery and scroll down and find a little fish. Now, our game is going to scroll from left to right, kind of like you would read a book. So we have to flip our character. On the top left-hand side of the window that popped up, there will be options to flip your character. We're gonna flip our fish on the y-axis so he's facing the right side of the screen. Once that is done, you're gonna hit the Done button on the bottom right, and you should have selected your little character. Very exciting. Now, next, we have to make sure that our character actually is going to move. So we are going to go into the controller box and find the item that says Move My Sprite with Buttons. You're gonna drag that out and put it right beneath the Set My Sprite that we put in just before. So this will allow you to move your character with the arrow keys or the WASD keys on your keyboard, and soon on your Pi badge as well. But we are going to actually test it out first. So you're gonna plug in your Pi badge, the USB into your computer, the small end into the Pi badge. It should turn right on. Very exciting. If it doesn't work the way it's supposed to, we do have troubleshooting information listed on the website as well. So to connect it, you're gonna go down to the bottom left of your screen, and there's a button that says Choose Hardware. You're gonna click that and select the Adafruit Pi badge. Once you've done that, you have to go back to that same little button in the bottom left, and you're gonna click Connect a Device. Once you do that, a little window should pop up that will either say Pi badge, or it might be a little different than that, but there should be an option that pops up. If there isn't, go through our troubleshoot guide, but you'll just select that option and you should be good to connect. So we're gonna try and download our code now. So back in that bottom left-hand corner, you're gonna click Download. It should pop up on the screen and load. We'll wait and we'll see if it uploads. But now, if you look at your screen, it has a little black screen and you have a fish on it that, if you use the buttons on the left-hand side of your Pi badge, should be able to move around corresponding with the buttons that you push. Super exciting. Now, we don't want our fish to react that way, so there's a couple things that we have to do to fix that. We are going to, on that Move My Sprite with buttons, we're gonna click the plus sign that's at the end of that line, and there should be two little text boxes that pop up, one labeled VX and the other labeled VY. On the VY one, we're gonna delete where it says 100 and just type in 0. That way, your up and down buttons aren't going to affect your fish's motion. So next, we have to make it so that your fish can accelerate, so that it can speed up. So for that guy, we are going to go into your sprites category, and you're going to select the Set My Sprite, and then it'll say X with a little drop-down arrow, 2, and then a number. So we're gonna select that guy, drag it in right below your latest box that says Move My Sprite with buttons, and we are going to change the X with the drop-down button to say AY, or acceleration Y. Next, you're gonna click in that little text box and change that to 50. That will make it so that your sprite moves at the speed that you expect it to. Now, your sprite in the little play in your window on your computer, it's going to just fall, but we will fix that. So next, we have to create a tile map, or the background of your game. So if you're playing a video game, it's the part that your character is interacting with. So in like Super Mario, it's the ground and the stuff that you jump over. So to do that, we are going to go into Scene, click that up, and we are going to scroll down until you see a box that says Set Tile Map to, and then Tile Map. You're gonna drag that out and put it right below that latest box. So it should be at the bottom of your OnStart alligator. So now you get to be a little creative. I think this part's fun. And you're gonna click where it says Tile Map and has that little box next to it. You're gonna click that box and a new window should pop up for you. Kind of like the one that we had for when we did our sprite. You are going to first change the size of this little play area so that it works a little better for the type of game we're making. Because we're making a platformer, we want it to be longer than it is wide so that you have a little more space for your character to move. So we want ours to be 75 by 25. So there's little text boxes at the bottom. You will change those and it will resize your screen. Next, you get to choose what you want your barriers to be, because we're gonna make a bit of a maze. So I'm gonna go down in the drop-down box on the left-hand side that currently says forest, and I'm gonna click aquatic, because then you can get some ocean-themed bricks. And you're just gonna select one that you like. I'm gonna select the one that looks a little bit like seaweed, and we're gonna make a maze. So we're gonna make some vertical lines, and you just draw those in by clicking. And you wanna make it a little difficult, but you wanna remember that you still have to get your sprite through. So you wanna give yourself enough space that you have a way for your character to travel. So we're gonna make our little map. It's all good if the lines aren't straight. Just make it fun. This is the part where you get to be creative, so you can use any kind of block you want. You can make your game any kind of theme. I think that's fun, because you can always change it up. And once you have your tile map all set like that, we have to make the obstacles that your little fish is gonna swim into. So for that, I am going to choose a little bubble block, and I'm just gonna add some of those in right in the path where your fish is gonna swim through. And these are going to act as how it's gonna take away a life for your character. So like if you were to run into a wall, you wouldn't feel good. So we want our fish to have something that'll react with it. So once you've added those in kind of sporadically throughout your game, we are going to do something very fancy, which is adding walls. So this will make it so that your maze that you've created is solid, so that your fish can't just swim through the maze or straight through a wall, because that's not how walls work. So to do that, you're gonna click the Make Wall button, and you're gonna draw right over top of all of those maze lines that you made. Not over top of the obstacles that you added, so those were the second guys that we added, just over top of the walls. and that will allow it to block your character, so we can have the game interact with that a little differently than other colored blocks. So once you've created your whole maze and you're quite happy with your tile map, we're gonna click done, and you're back on your main canvas screen. We're gonna go back into scene and select an option that says camera follow sprite, my sprite. That will make it so that your screen on your Pi badge is going to move to follow the fish's action, so that your fish will never swim off the screen. If we don't use this, your fish is gonna just keep swimming and swimming and swimming and swimming and disappear. So we don't want that to happen. We want your game to be able to react to the fish's motion, and that will help it do so. So next, we want to find a way to create the up and down motion for your fish to make it float up like it's swimming. So this is a new little section of your code. So we are going to go into controller, and there is an option that looks kind of like our on start option with the alligator mouth, but this time it says on A button pressed, and it has that alligator mouth. So we're gonna drag that guy out onto our canvas below our on start block, because we want it to be completely separate, because this is not going to happen right when you start your game, but it's an event that happens during your game that we want it to react to. So to make your sprite move based on that A button being pushed, or if you're doing it on your computer, this is the space button, we are going to go into sprites, and we are going to go into that same one that we grabbed before, set my sprite X to 0. We're gonna drag that out, and we're going to change it to set my sprite velocity Y by clicking that drop down arrow, and we're gonna change that to -80. So that seems a little weird. Video games can be a little confusing with the way that they do their coordinate systems, but this is going to make it so that our fish goes up. Seems a little backwards, but because we had our sprite's acceleration set to 50, that makes it drop, so we want to counteract that drop. So next, we have to make it so that when our fish interacts with those obstacles that we added, so I added the purple bubbles, we want it to react properly to those. So we're gonna go back into that scene box on the left-hand side. We're gonna scroll down, and we're gonna find the one that says on sprite of kind player, because that's what we are, we're the player, overlaps, and then it has a little grid spot at location. So we're gonna drag that out. It's again one of those alligator mouth shaped ones, so you want it to be completely separate from all of your other code. So now we're gonna change what it's overlapping with. So to do that, you're gonna click the drop down arrow that currently has the little gray checkerboard in it, and you're going to select the option that is your obstacles. So for me, that's the purple bubbles. For you, it might be something totally different. That way, it knows what color to react to. Once you've done that, we're gonna go back into scene, and we're going to select the option, you'll have to scroll down again for this one, that says place my sprite on top of random, and then it has that little checker box again. So we'll drag that right into the middle of our newest section of code. So that section should be all just scene colored, so the dark blue color. And we want that to stay as moving your sprite to a random just grid box. So we don't want to touch that one at all, because then it'll move your fish or whatever sprite you chose to a completely new spot on your game to make it a little more challenging. So next, we've set it so that our fish moves. We've set it so that it can't run into walls. We've set it so that your fish, if it overlaps with some of your obstacles, that it moves, but we need to have it react in some way to make your game a little more difficult. So to do that, we're going to add the functionality of lives. Typically in video games, you have about 3 lives, so that's what we're gonna do. So you're gonna go into info, and you scroll down a bit, there's an option that says set life to 3. We're gonna drag that out, and we're gonna put it at the bottom of our green on start section. That way you always start with 3 lives, and we can adjust it from there. Now, we've set our lives, but we need to make it so that it changes. So you're gonna go back into that info section, and you're going to do the change life by -1. So that will erase a life every time that you hit one of your purple blocks. So we're going to put that at the bottom of our last block of code, or the one that says on sprite of kind player overlaps with your purple bubbles or whatever obstacle you chose. And we're gonna put it at the very bottom of that section. So that will make it so that when you hit your purple bubbles or whatever obstacle you chose, your sprite will move to a random spot and you will lose a life. So now what we're gonna do is we are going to make sure that our tile map is working properly. This is a little bit tricky, so you wanna make sure that you follow it really closely. We're gonna change our tile map, so we're gonna go up, and where you had the set tile map to tile map, you're gonna click that guy again, and you're going to choose a completely new colored tile. So I'm going to just find a random one from somewhere. I'm gonna choose just a brick pattern. You can use whatever you want, but we're gonna select that, and we're just gonna draw a line on the very right-hand side of our tile map. And this is going to be what our little fish is going to run into to win the game. So you're just gonna draw a line with that straight from the top to the bottom so that your fish knows, if I run into this color, I'm done. So once you've drawn that, you just have to click done. And we have to set one more option in our code. And that is, we're going back into that scene one, the same one as the last one we used. We're gonna scroll down and use the on sprite of kind player overlaps with a certain color block. We're gonna drag that out, and we're gonna change what it's overlapping with that tile that you just chose for your end of your game. So I'm gonna choose the little brick pattern because that's what I picked. So now that we have it so that it will do something when it touches, we need to choose what it's gonna do. And for that one, we're gonna go into game, and we are going to find the one that says game over. These ones are all purple. We're gonna drag out the one that says game over and put it right into that latest alligator mouth. And currently it says game over, lose. We don't want it to lose then because we've made it to the end of our game. So you're gonna click where it says lose, and it should toggle to say win. Now, our code should be finished. As long as everything has its full color, everything is connected properly. If any of your blocks look dull in color, that means that they're not connected properly. So we want to make sure that they're all kind of clicking in like Lego bricks. So now, as long as our code is good, we should be ready to re-download our code. So just like before, as long as you haven't unplugged your Pi badge, you should be good to just click download. Your screen's gonna load. Might take a little bit because we've made a pretty cool game. So to play your game, you're gonna use the arrows on the left-hand side of your Pi badge, the left and right arrow buttons. They're not labeled as arrows, but they're the left and right ones of the D-pad, or the 4 buttons in a diamond shape. So that will move your character left and right. To make it jump, or to have vertical acceleration, you're going to click the A button on the right-hand side. And that's our game. So you can try and play your game, and as long as your Pi badge is connected to a computer, it will have power. You can make any changes to the code. You can click a different character. You can make it harder or easier, depending on what you would like. You can always make it so that it's harder by changing the amount of lives you have. If it's too hard for you, you can always delete some of the walls in your game, but you've completed your first ever game on your Pi badge. Congratulations. So, now that we've done that, that is the end of our game. I hope you all enjoyed making Ocean Swim and enjoy the rest of our fun day.